Okay, today we're talking about solving equations. This is 2.5, and we're going to use one step to solve equations today. We're starting off easy. We'll just continually build as we go through the rest of this chapter and the next chapter. So by the end of this, you're going to be pros at solving big equations. But right now, we're starting very easy. There are two terms we need to know before we start solving equations. The first one is inverse operations. And these are two operations that undo each other, such as addition and subtraction. Such as if you start out with, say, 4 quarters, you add 2 quarters, and then you take away 2 quarters. You end up with what you started with. Addition and subtraction, they undo inverse operations. Equivalent equations are equations that have the same solution. And I have 2 examples of this, or one example of equivalent equations. X equals 4. Well, x equals 2 here, right, to make this true, and then x plus 2 equals 4, x has to be 2. These are equivalent equations because they have the same solution. The solution is 2. Okay, so inverse operations and equivalent equations. The addition property of equality is something else we need to understand. It's not that we have to recite it verbatim, but we need to understand this. Adding the same number to each side of an equation produces an equivalent equation. Okay, so let's start out with something. Let's start out with x equals. According to the addition property of equality, if I add the same number to both sides of the equal sign, or the equation, I get an equivalent equation. So let's add 4 to both sides. X plus 4 equals 3 plus 4. Okay, so I added 4 to both sides. Is x still the same here as it was here? Okay, x is 3 here, right? X has to be 3 for this to be true. So is x 3 right here? Well, 3 plus 4 is equal to 3 plus 4. So x is definitely the same here. So what I have is an equivalent equation. These are equivalent. Okay, so right now I've got x plus 4 equals 7. Let's subtract something. Let's subtract 2 from both sides. So x plus 4 minus 2 equals 7 minus 2. Well, simplified, that is simply x plus 2 equals 5. Okay, is x still the same here as it was up here and as it was here? Is it 3? Yes, the solution here is 3. So we have an equivalent equation. Okay, and we can see that by adding the same thing to both sides of the equal sign and by subtracting the same thing from both sides of the equal sign, we get equivalent equations. So we don't change the solution when we do that. If I started off with x equals 3 and I just added it to one side, let's say I add 2 to this side but not to this side, well, that means x equals 5. Okay, but here x equals 3. So I can't add something to one side of the equal sign. Whatever I do over here, I have to do over here so that this stays the same as this, okay? So again, the concept here is doing whatever you do to both sides of the equal sign, the exact same. You will keep the equation equivalent. Okay, moving on. Solve the equation, check your solution. Now what I'm going to show you is how we're the way I want you to do it. I will show you how on this. So I want to see exactly the way I do it on the board on your paper. Okay, let's look at x equals 8. X plus 8 equals 19. What we want to do is get to the point where x equals something. Okay, that way I'll know the solution. I'll know what x equals. Now, can we do this in our head? Yes, we can, but we're starting off with simple things so you can learn the steps. So when we get difficult things that you can't do in your head, you'll know exactly how to do them. Okay, so what I want to do is get x here by itself on this side of the equal sign. Okay, so over here on this side I just want x. Well, what's with x that needs to go away? The 8. So what I'm going to do to create equivalent equations, remember when I do to one side of the equal sign I need to do to the other, and I want 8 to go away. What's the inverse of plus 8? Well, the inverse of adding 8 is subtracting 8. If I subtract 8 from here, and then I subtract 8 from this side of the equal sign, I get an equivalent equation. Positive 8 and negative 8 cancel, and then I have x by itself. Right here, I have the equal sign, then I have 19 minus 8. Well, what's 19 minus 8? That is 11. So x equals 11, and we have solved. Now, obviously I drew arrows and stuff like this. All that is not needed, okay? But I need to see the step just like this, and then the solution circled just like this. Okay, let's look at this one. Y plus 13 equals negative 7. What's with the variable over here that I need to take care of? Well, positive 13. Okay, so what I need to do is undo that by doing an inverse operation, which is subtract 13. Okay, so if I subtract 13 here, I need to do the same thing on this side of the line, on this side of the equal sign. So I'm going to subtract 13 over here. Okay, so 13 minus 13 is 0. That cancels. What's left over here? Well, y is. And the equal sign is there. Now I've got a negative 7 plus a negative 13. Okay, negative 7, negative 13. That gives me negative 20. So y equals negative 20. Okay, next, we've got x minus 4. This is subtracting 4 right here. So what's the inverse of subtracting 4? Well, adding 4. And remember, I always look to the side with a variable to solve this. So I want to look to the variable side, not over here at this. I'm going to know what to do by looking over here at the variable side. So I need to undo the subtraction. So I do the opposite, which is addition, plus 4. Now what I do over here, I have to do on this side of the equal sign, plus 4. I get x equals, well, negative 11 plus 4. We're going to subtract because they're different signs. So I get 7, and it's negative because 11's negative. There's my answer. Okay, again, I had to see this step and then this answer. I always put a line on the equal sign. We did that at Lee for some of the kids, and it really helped them to know where the division line was. You don't have to do that, but I always do that because some kids like it. Okay, again, what needs to go away? Well, the minus 61. What's the opposite? Plus 61. I need to add 61 to both sides. Okay, that cancels. I get x equals, now I've got 26 plus 60. Positive or negative? It is positive. Positive, I had to undo it by doing subtraction. Positive 7 minus 7 should cancel out. Okay, what's left over here? X. Now I have to subtract 7 from this side. 13 minus 7 is 6. X equals 6. Okay, here, look to the variable side. What's with x? Well, negative 5. How do I make negative 5 0? By adding 5, doing the opposite. An inverse operation. If I add 5 to this side, I have to add 5 to this side. This cancels. I got x equals negative 10. Negative 15 plus 5 is negative 10. Okay? Let's look at another page. Solve the equation, check your solution. Again, except we've got an extra step here. We've got two constants, here and here, with the x. All we have to do is simplify. We know how to add like terms. The two constants are like terms. So I'm going to add 5 and negative 8 together as my first step. So x doesn't change, but 5 plus negative 8 is negative 3. So that's x minus 3 equals 7. Now I'm back to where I know what to do. I've got x minus 3 equals 7. I want to do the opposite, which is add 3. So x equals 10. Okay, again, add like terms, then do inverse operation. Do an inverse operation and get the answer. Here again, I've got like terms. Negative 2 and positive 13. Well, I need to add those together. That gives me positive 11. So x plus 11 equals 5. Inverse operation. I want to get rid of the 11. I look to the side with the variable right here. What's it telling me to do? I need to get rid of 11. So I subtract 11. And I subtract 11 here. X 11 minus 5 is 6. And 11's negative, so 6 is negative. And there's our answer. So here we did two steps. Combine like terms, and then subtracting. Okay, and we got the answer. Let's look at this triangle. Now, we know the perimeter is 34. How do we find the perimeter? Well, we did this yesterday. What you have to do is add all the sides together. Well, we don't know what one of the sides is, but so we call it x. You know, we don't know the length of that side. So I'm going to add all the sides together. X plus 11 plus 14. What does that equal? Well, it equals the perimeter, 34. Okay, now I just need to solve the equation. I'm going to add like terms. That gives me x plus 25 equals 34. One more step. I want to get rid of, I look to the side with the x, and I want to undo what's being done to the x. It's almost like I'm unwrapping a gift, and I'm getting down, the x is the present, okay? The thing inside the box, okay? So I want to unwrap it. I'm going to subtract 25 from both sides. Okay, x equals 134 minus 25 is positive 9. So this side length is 9. Again, just using perimeter. Here in what we have to do for perimeter is add all the signs, and we just set up a simple equation. We added like terms. We subtracted from both sides to undo what was being done to the x. And then we got the side length of 9. Next page, always want to throw a word problem in there just to kind of keep us sharp on word problems. A plumber charges $195 for parts and $45 per hour. Well, I would say this is important. Don't know what we're asking yet. Well, I do know because I wrote the problem. But $45 per hour sounds important. Write an expression for the total amount the plumber charges for a job after working H hours. Well, what is this thing, this word, per? What does that mean? It's a rate. It tells you rates are multiplied to something. What is this one multiplied to? Well, dollars are multiplied to hours. Per is like a product. It's a rate, but it's like a product, okay? It's telling you to multiply. Okay? So H here represents hours. So what I'm going to do with the 45 and the H, I'm going to multiply them together. Okay? Then I'm going to add whatever he charges for parts, and I'm finished. I wrote it. That's $195. That's a pretty poor job of writing that. Okay? Here's the expression for the plumber for the part job that does. Okay? $45 per hour. $45 times hours. Plus $195, which is what he had before.